back to my channel. Today we're gonna work on the question min cost climbing stairs. It's an easy level question. The question states you are given an integer array cost where cost I is the cost ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or the step with index 1. Return the minimum cost to reach the top of the floor. So let's look at example 1. If cost is 10, 15, 20, then we can either choose 10 and then go to 20, which will be 30 until we reach the top, or we can choose just 15 and then we jump 2 steps here, which is the total would just be 15. And let's look at example 2. We can either go 1, then we skip the big number and then go here, and then we skip to here. So 1 plus 1, 2, plus 1, 3, and then we skip to here, 4, and then we go here, 5, and then we skip this one, 6. So it's a total of 6. This is also a dynamic programming question. To solve this, we can do a top-down recursive solution. So any recursion, we'll need a base case, and because we're doing dynamic programming, it's like optimized recursion with memoization. We'll always have like a memo dictionary to store the previous steps of how we reach there, so we don't do repeated calculations. And then I'm gonna write a dp function where it takes I is the index of the step, and we first check what's our base case. So the question says we can either climb 1 or 2 steps. So it means if we climb here, the cost of climbing to 10 would be 0. Or if we, it would just be itself, right? Or if we climb to 15, there's no additional cost, it would just be 15. So if I is smaller or equal to 1, we would return 0. It means to get there, the cost of getting there would just be 0, from either to 10 or to 15. And if I not in memo, then we want to update our memo of the I index. Memo I equals minimum. We want to get the minimum of either climbing 1 or 2 steps. So minimum dp I minus 1 plus cost of I minus 1, or the minimum of dp I minus 2 plus the cost of I minus 2. And if it is already in memo, we just return memo I. And we need to feed the index into this dp, so we're gonna feed it length of the cost. We do length of the cost instead of cost minus 1 because eventually we want to reach the top floor. But what's the top floor? It's like the imaginary index 3. So this is index 0, 1, and this is index 2, and this would be 3 here. So that's why we want to calculate the minimum to get to the top. So this would basically feed the dp length of cost. Let's say this is our cost list, so it would be 3, and memo 3 is not in our memo, so we check the minimum of climbing to this imaginary top floor if we would pick 20 to climb here or 15 to get there, and the minimum of the cost. So cost is 15 itself, like minus 1 would be 20, minus 2 would be 15. So it would be like 20 plus whatever is the minimum to get to 20, or 15 plus whatever was the minimum to get to 15, and the recursion goes down until we reach our base case, and we either are on step index 0 or 1, and then we return 0, and everything backtracks and return the memo at 3, and then we return the minimum cost of 15, because the minimum amount of steps to get to this imaginary top floor would just be 15. And for our function, we're going backwards, so we start at the top floor and then we go backwards. Let's try running this and submitting. Yeah, so this is how I would solve this question. Let me know if you have any questions, and thank you so much for watching.